It was May of 1944. The air at Fort Monmouth, New Jersey, carried the smell of heated metal and machine oil. The afternoon sun streamed through the dusty windows of the communications shed, casting golden streaks across benches strewn with valves, resistors, and disassembled radio chassis. The constant hum of the generators created a never-ending industrial melody. In this forgotten corner of the American arsenal, far from the beaches of Normandy and the forests of Germany, war was fought with soldering irons and technical diagrams. But before we continue, I want to hear from you. Where are you watching this video from right now? Comment below with your city or country. It's always impressive to see how far these stories reach across the globe. Now let's go back to that warehouse, where it all began. The US Army faced a silent but devastating problem. Armored units advancing through France relied on SCR-38 field radios. These were rugged devices, built to withstand dust, rain, and the impact of moving tanks. But they had a critical flaw. Their maximum range in open terrain was 5 kilometers. In dense forests or deep valleys, that distance was cut in half. Platoon commanders lost contact with their superiors. Orders arrived late. Soldiers died from lack of coordination. The radio, which should have been the backbone of modern tactics, became a dead weight when it was needed most. Signal Corps engineers worked day and night to find solutions. They tried increasing transmitter power. They tested new antennas. They modified modulation circuits. Nothing worked without compromising the equipment's portability or durability. The war didn't wait. Every week lost to testing meant more isolated platoons, more successful enemy ambushes, more reports of failed missions due to communication failures. An official solution was a long way off. Perhaps it would take months. Perhaps it would arrive too late. It was then that a private first class named Thomas Eugene Hartley decided to ignore protocol. He was 26 years old, a native of Detroit, Michigan. Before the war, he had worked as a commercial radio technician, repairing devices in the homes of families who still listened to variety shows and news broadcasts from distant Europe. Hartley was not a trained engineer. He had no college degree, but he understood circuits like few others. He saw technical diagrams not as abstractions, but as maps of familiar territory. To him, each resistor was a road, each capacitor a bridge, each valve a gate that could be opened or closed with surgical precision. He watched the other technicians follow the manuals to the letter. They replaced burned-out parts, adjusted frequencies, and calibrated power within established limits. Everything was as per specifications. Everything was safe. Everything was ineffective. Hartley knew the solution wasn't to make the radio work better within the rules. It was to break the rules intelligently. He began working alone after hours, when the warehouse was empty, and only the light of a single bulb illuminated his workbench. He didn't ask for permission. He didn't notify anyone. He simply picked up a damaged 38-inch SCR, destined for disposal, and began disassembling it piece by piece. The modification Hartley had in mind was risky. He wanted to alter the transmitter's oscillator circuit, increasing the stability of the carrier frequency. This would allow for a wider modulation range, improving signal clarity and potentially range. But there was a problem. Any misadjustment could render the radio unstable. It could interfere with other frequencies, cause noise in nearby equipment, or simply burn out the entire circuit on the first transmission. If caught, he would be charged with sabotage of military equipment. If it failed, it would prove that a private soldier lacked the ability to modify army technology. If it worked, it might change the way thousands of men communicated on the battlefield. The silence of the empty shed was broken only by the clang of tools against metal. Hartley breathed slowly. His hands didn't shake. The first modification took 4 consecutive nights. Hartley worked between 10 p.m. and 2 a.m., when only a sleepy guard circulated the base's outer perimeter. He turned off the main lights and used only a desk lamp, positioned so that light didn't leak through the windows. The SCR-38 radio lay completely disassembled before him. The chassis was open, the valves removed, the wires exposed like the veins of a mechanical organism. He started with the master oscillator, the heart of the transmitter, responsible for generating the carrier frequency that carried the voice through the ether. The original problem was thermal drift. When the radio warmed up during prolonged use, the frequency would fluctuate slightly. Under normal conditions, this was tolerable. But over long distances, this instability accumulated distortion. The signal arrived garbled and unintelligible. Hartley needed to stabilize the frequency without increasing power consumption, adding weight to the equipment, or using components that weren't readily available in the warehouse. It was like trying to repair a clock, using only the parts from another broken clock. He replaced the original variable capacitor with a more thermally stable silver mica model. Then he modified the feedback circuit, reducing the amplification by 2 stages, but increasing the linearity of the response. This would slightly decrease the signal's raw power, but dramatically improve its coherence. A weaker, cleaner signal travels further than a strong, distorted one. It was basic physics, but applied in an unconventional way. Military manuals discourage this approach. Official engineers considered sacrificing power for clarity risky. Hartley silently disagreed. On the 3rd night, he worked on the modulation stage. The SCR-38 used amplitude modulation, a reliable technique but susceptible to atmospheric interference and industrial noise. Hartley couldn't change the basic principle without rebuilding the entire radio, but he could optimize the way the human voice was converted into an electrical signal. He adjusted the audio transformers, altered the microphone's response curve, and added a makeshift low-pass filter using an inductor taken from a commercial radio he had brought from home. The filter would cut high frequencies above 3000 Hz, those that caused hiss and consumed bandwidth without carrying useful information. The voice would be slightly muffled, less natural, but would remain perfectly understandable even through heavy static. The biggest risk lay in the antenna. Hartley knew that a transmitter's range depended not only on its power output, but also on the efficiency with which the energy was radiated into space. The standard SCR-38 antenna was a 7-foot-long vertical whip designed to be mounted on vehicles or portable tripods. It worked well but was far from ideal. Hartley calculated that by adjusting the feed point and adding a makeshift horizontal counterweight, he could increase the radiating efficiency by up to 20%. This required no special components, just copper wire, solder, and a knowledge of antenna theory. He sketched the design on a piece of wrapping paper, triple-checked the calculations, and began assembling the prototype using scraps of field cable he found in a forgotten corner of the shed. By the 4th night, everything was ready. The modified radio was reassembled, the tubes reinstalled, the wires carefully reorganized inside the chassis. It looked identical to the original, except for small details only an experienced technician would notice. A different capacitor here, an additional inductor there. The antenna had a subtly altered configuration. Hartley connected the equipment to a power supply, adjusted the controls and turned on the transmitter. The tube's warming produced a soft orange glow. The power meter rose slowly until it stabilized. The radio was working. But was it working as it should? Hartley had no way to test the actual range in there. He needed open ground, distance, and real operating conditions. He waited until dawn. At 5:30 a.m., the warehouse began receiving the first technicians from the day shift. Hartley packed the modified radio into a standard shipping crate, grabbed the dismantled antenna, and walked to the test yard, an open area at the back of the base where equipment was evaluated before being sent to the front. He mounted the radio on a tripod, extended the modified antenna, and turned on the transmitter. 200 meters away, a friendly technician named Robert Klein was waiting with a standard, unmodified receiver tuned to the same frequency. It was a simple test. Hartley would transmit a message. Klein would confirm that reception was clear. Hartley pressed the transmit button. He spoke slowly, enunciating each word clearly. Test Station 1 to Test Station 2, requesting confirmation of reception. Over. He released the button and waited. The silence lasted 3 seconds. Then Klein's voice came from the receiver, crystal clear. Test Station 2 to Test Station 1. Reception confirmed. Strong and clear signal. I repeat, strong and clear. Over. Hartley felt the weight of 4 nights of work drain from his shoulders. But 200 meters proved nothing. They had to go further. They repeated the test at 500 meters, 1,000 meters, 2 kilometers. At each distance, the clarity remained astonishing. The signal not only reached farther but remained intelligible even as the power began to drop. At noon, a Signal Corps captain named Andrew Mercer noticed the movement and approached to investigate. Hartley's blood ran cold. Modifying military equipment without authorization was a serious offense, but it was too late to hide. Mercer looked at the radio, then at Hartley, and asked what was happening. Hartley took a deep breath and explained everything. The nights of work, The technical modifications, the test results. He expected a reprimand, perhaps a formal punishment. Mercer was silent for a long minute. Then he asked to see the diagrams. Hartley showed him the sketches scrawled on wrapping paper. The captain examined every line, every calculation, every marginal note. Finally, he looked up and said just one sentence. "We need to test this under simulated combat conditions." It wasn't official approval. It wasn't an order. It was something in between, a grey area where military necessity met individual initiative. Mercer had seen reports from the front. He knew men died from lack of communication. If this crazy modification worked, it would be worth any bureaucratic risk. If it failed, Hartley would bear the consequences alone. The simulated combat test was scheduled for the following week. Captain Mercer organized a tactical exercise involving 3 infantry platoons and 2 Sherman medium tanks, simulating an advance operation through mixed terrain. The chosen scenario was the Fort Dix training area, about 30 miles south of Fort Monmouth. There, wooded hills alternated with open valleys and marshy areas, replicating the conditions American troops faced in France. The objective was simple: maintain constant communication between units during 6 hours of maneuvers, using both standard radios and the equipment modified by Hartley. Direct comparison would reveal whether the modification offered a real advantage or was merely a laboratory anomaly. Hartley spent the next few days preparing 3 additional units. He was now working openly, with Mercer's tacit permission, but without official documentation. Each modified radio took approximately 12 hours of meticulous work. He couldn't rush the process. One soldering error, one miscalibrated component, and the entire system would fail under pressure. Other technicians in the warehouse began to watch him curiously. Some asked what he was doing. Hartley responded with polite vagueness. Just some preventive maintenance adjustments. No one pressed further. Everyone knew that too many questions could complicate already delicate situations. On the morning of the exercise, the sky was overcast. Low, heavy clouds promised rain before noon. The high humidity created adverse conditions for radio wave propagation, exactly the kind of environment where conventional SCRs showed their limitations. Hartley installed one of his modified radios in the Sherman tank designated as command and distributed the other 3 among the infantry platoons. Standard radios were installed in the remaining units. All would operate on the same frequency, allowing direct performance comparison. At 7 in the morning, units began dispersing across the training area. The exercise simulated a coordinated advance to capture a fortified enemy position located 8 kilometers away. Communication was essential. Each platoon had to report its position every 15 minutes, respond to course adjustment orders, and coordinate flanking movements with supporting tanks. For the first 30 minutes, all radios worked perfectly. The distance was still short, the terrain favorable. Voices came through clearly, and orders were carried out without hesitation. But as units entered the wooded areas, and the separation grew beyond 3 kilometers, differences began to emerge. Platoons equipped with standard radios reported increasing interference. Transmissions became choppy, fragmented by bursts of static. Whole words disappeared. Operators had to repeat messages 2-3 times. Frustration was audible in voices struggling to be understood. One platoon lost contact completely for 12 minutes until it managed to reposition itself to higher ground. The modified radios, on the other hand, maintained remarkable clarity. The signal was weaker in raw power, but remained coherent. Voices sounded slightly muffled, as Hartley had predicted, but every word was perfectly intelligible. Operators didn't need to shout. They didn't need to repeat themselves. Communication flowed with quiet, almost anticlimactic efficiency. That's exactly how it should be. Effective military communication isn't dramatic. It's invisible. It works without drawing attention to itself. At noon, the rain began. It wasn't a violent storm, but a persistent drizzle that turned trails to mud and created dense fog in the valleys. Radio conditions deteriorated dramatically. Moisture in the air absorbed electromagnetic energy, reducing range. Atmospheric static increased. 2 of the platoons with standard radios lost contact with command. One managed to re-establish communication after 20 minutes of frustrating attempts. The other remained silent for nearly an hour. In real combat, this unit would be isolated, vulnerable, unable to request support or receive orders to withdraw. Men could die in this silence. The units with Hartley's radios continued operating. The signal weakened, yes, The static increased, but never to the point of obliterating communication. The operators quickly learned to speak more slowly, to pause between sentences, to let the technical clarity of the equipment do the heavy lifting. It was a subtle dance between human and machine, each compensating for the other's limitations. Hartley monitored everything from the command station, headphones pressed to his ears, notebook open on his lap, jotting down every detail. He didn't smile. He didn't celebrate. He simply observed, analyzed, absorbed data. At 15 now, the exercise concluded. The units returned to their starting point, muddy, tired, but technically successful. Captain Mercer gathered the radio operators and asked for honest reports. The men using standard equipment described constant frustration, lost messages, and the need for tactical repositioning just to re-establish communication. Those using the modified radios reported consistent operation without significant interruptions. The difference was not small, it was abysmal. Mercer looked at Hartley and asked a direct question. "How many of these can you produce per week?" Hartley did quick mental calculations. If he worked alone, perhaps 4 units. If he had help from other competent technicians, perhaps 10. But there was a bigger problem. The modification was not officially documented. There was no technical manual. There was no chain of command approval. There was no standardized procedure. Each modified radio was technically an unauthorized deviation from military specifications. Producing dozens of them without formal approval would be crossing a dangerous line. Mercer understood the dilemma immediately. He had 2 options. He could submit the modification through official channels, wait months for engineering review, formal testing, and bureaucratic approval. Or he could act within the gray area, classify the modifications as field adaptations, and begin producing units immediately for shipment to the European theater. The first option was safe, but slow. The second was risky, but would save lives now. Mercer was not a man to hesitate when lives were at stake. He authorized limited production. 50 modified units would be prepared over the next 3 weeks and sent to armored units operating in France. If they performed well in actual combat, the bureaucracy could be adjusted later. If they failed, Mercer would bear the consequences. Hartley was assigned 2 technical assistants. He set up a makeshift production line in a secluded corner of the warehouse. He created handwritten checklists, simplified diagrams, and step-by-step procedures. Each radio was rigorously tested before being packaged. Quality could not be sacrificed for speed. He worked 14 hours a day, 6 days a week. His hands developed new calluses. His eyes burned under the constant artificial light. But the work progressed. 10 units in the first week, 18 in the second, 22 in the third. In mid-June of 1944, the first boxes were loaded onto a military transport bound for New York Harbor, from where they would be shipped to Southampton, England. Hartley never knew which units received his radios. He never received direct feedback from the troops who used them. War didn't work that way. Equipment was shipped, used, destroyed, replaced. Anonymity was total. But 3 weeks after the first shipment, Captain Mercer entered the warehouse with a classified telegram. It was brief, almost cryptic. An armored unit operating near the town of Carentan had reported exceptionally reliable communication during operations in difficult terrain. The commander requested more of the new model radio. There was no mention of Hartley. There was no formal thanks. Just a matter-of-fact request for more working equipment. July of 1944 brought sweltering heat to New Jersey. The communications warehouse became an oven in the afternoons, with temperatures inside exceeding 98 degrees Fahrenheit. Industrial fans merely circulated hot air. Hartley and his small team worked in sweat-soaked shirts, pausing only to drink water and clean their hands before handling sensitive components. Production continued. 50 more units were ordered, then 70 more. Demand grew faster than production capacity. Other technicians in the warehouse began asking more pointed questions. What exactly made those radios different? Why were only Hartley and his assistants allowed to work on them? The official answer remained vague, but rumors were beginning to circulate around the base. Some said Hartley had developed revolutionary technology. Others speculated that he was simply lucky and that the radios worked so well by chance. Hartley didn't respond to any speculation. He kept his head down, his hands busy and his mouth shut. Letting the work speak for itself was safer than feeding narratives he couldn't control. In August, something unexpected happened. A Signal Corps major named Richard Kellerman arrived at Fort Monmouth unannounced. He had come directly from the Supreme Headquarters Allied Expeditionary Force in England. He brought with him detailed field reports on the performance of communications equipment in the European theatre. Kellerman was no desk clerk. He had spent 3 months visiting combat units, observing operations and collecting data from primary sources. He knew exactly what worked and what failed under live fire. Kellerman requested a private meeting with Captain Mercer. The conversation lasted 2 hours. When they left the room, Mercer had a tense expression. Kellerman seemed pleased, almost excited. They walked directly to the shed and asked to speak with Hartley. The soldier wiped his hands on a rag, adjusted his sweaty uniform, and followed the officers to a rarely used briefing room. Kellerman got straight to the point. Armored units equipped with the modified radios reported a communication success rate 42% higher than average. This wasn't an estimate. This was data compiled from operational reports from 17 different platoons operating in a variety of conditions: forests, hills, plains, rain, fog, urban combat. Hartley's radios simply worked better. Company commanders specifically requested the equipment. Some even traded radios between units to ensure their troops had access to the modified models. A private soldier's unauthorized modification was altering field tactics. But there was a problem. The modification had no official documentation. It didn't appear in technical manuals. It had no formal model designation. Maintenance technicians at the front didn't know how to repair it if something broke. Some tried to apply standard SCR-38 procedures and ended up destroying the modified components. The lack of standardization was creating logistical problems. Kellerman needed 2 things. First, complete technical documentation that could be distributed to all communications maintenance units. Second, formal authorization for industrial-scale production. Hartley felt the weight of the situation. Documenting the work meant exposing every technical detail, every unauthorized decision, every deviation from protocol. It meant transforming individual improvisation into official military procedure. It also meant taking full responsibility. If a radio failed catastrophically, if a unit lost communication at a critical moment because of his modification, he would be responsible. There would be no more gray area. Everything would be official, documented, and traceable. Kellerman noticed the hesitation. He pulled up a chair and sat next to Hartley, not in front of him as a superior, but beside him as a colleague. He spoke slowly, choosing his words carefully. He said he had already spoken with engineers from Bell Labs and RCA. All confirmed that the modification was technically sound. No one questioned the competence of the work. The only issue was bureaucratic. The Army needed to regulate what was already happening in the field. It wasn't about punishing protocol deviations. It was about systematically saving lives. Hartley asked for 24 hours to think. Kellerman agreed. That night, the soldier walked alone across the base grounds. The August night was clear. Stars dotted the sky like holes in black fabric. He thought of Detroit, of the radio repair shop where he'd worked before the war, of the customers who trusted him to repair their equipment. He thought of the men in France who depended on those modified radios to coordinate movements, request support, stay alive. He thought of the responsibility of having his technical decisions permanently documented, analyzed by engineers who'd never held a soldering iron, judged by officers who'd never heard the deathly silence of a radio failing at the wrong moment. The next morning, Hartley showed up at Kellerman's office. He agreed to document everything, but on one condition. He wanted the documentation to be technically accurate, without simplifications that could lead to implementation errors. He wanted enough time to review every diagram, every procedure, every calibration note. He wouldn't accept a rush that compromised quality. Kellerman extended his hand. The deal was done. The next 2 weeks were the most intense of Hartley's military life. He worked with a technical draftsman to create clean, accurate circuit diagrams. He wrote step-by-step modification procedures, including soldering techniques, calibration methods, and verification tests. He documented every replacement component, every value adjustment, and every technical rationale behind every decision. The result was a single-spaced, 132-page typed manual with 47 hand-drawn technical diagrams. The manual was classified as confidential and distributed to communications training centers at Fort Gordon, Georgia, and Camp Crowder, Missouri. Experienced technicians received 5 days of training on the modification procedures. The Signal Corps issued a formal technical directive designating the modification as Field Adaptation TB-SIG-44-3. It was not a new radio model. It was officially recognized as a field improvement approved for deployment in a combat zone. In September, production was transferred to Western Electric's industrial facility in Kearney, New Jersey. A professional assembly line replaced the traditional handicrafts in the warehouse. Production capacity increased from 20 units per week to 200. Hartley was sent to the factory to oversee the first batches, ensuring that civilian workers understood the critical aspects of the modification. He spent 3 weeks training line supervisors, adjusting procedures, and resolving quality control issues. By the end of September, nearly 1,200 modified radios were operational in the European theater. Field reports remained positive. A colonel in the 3rd Armored Division wrote that the modification had enabled effective coordination during the advance through the Hurtgen forest, where dense terrain historically disrupted radio communications. A captain in the 29th Infantry Division reported that his units maintained constant contact during night operations near Aachen, something they had never achieved with standard equipment. But it wasn't all praise. Some field technicians complained that the modification was too complex for high-pressure maintenance. Others reported that the weaker signal sometimes caused confusion, as operators expected high power and interpreted clarity as a distant signal. Hartley read each negative report carefully, noting recurring problems. He knew that no technical solution was perfect. The goal was never to create the ideal radio. It was to create something better than the previous one, something that saved more lives than it cost. By this criterion, the modification was unequivocally successful. In October, Hartley was promoted to corporal. There was no ceremony, just a service note and a pair of new chevrons. Captain Mercer handed them to him personally, accompanied by a brief handshake and a curt comment. "Don't let it go to your head. You still have work to do." Hartley smiled for the first time in months. He sewed the chevrons onto his uniform that very night, not out of pride of rank, but because they represented a silent acknowledgement that intelligently breaking the rules, when lives depend on it, is sometimes the most disciplined decision a soldier can make. The winter of 1944 arrived with brutal severity. In Europe, Allied troops faced snow, ice, and a desperate enemy fighting on familiar terrain. Communications became even more critical. Extreme cold affected batteries. Humidity froze connectors. Radio operators worked with numb fingers, struggling to keep equipment functioning in conditions that challenged the limits of engineering. In that context, every small technical advantage could mean the difference between effective coordination and deadly chaos. The reports reaching Fort Monmouth changed in tone. They were no longer just technical praise or requests for more units. They were human narratives. A sergeant in the 4th Armored Division wrote of an ambush averted because his unit was able to alert others to enemy movement, something impossible with the old radios that consistently failed in that wooded valley. A lieutenant in the 28th Infantry Division described how he maintained contact with 3 scattered platoons during 48 hours of continuous combat near Bastogne, orchestrating a coordinated withdrawal that saved dozens of men. Hartley read these letters alone late at night when the warehouse was empty. They weren't addressed to him personally. They were operational reports, cold technical documents catalogued in military archives. But each line carried an invisible weight. He would never know these men. He would never hear their voices beyond the words typed on official paper. But he knew, with absolute certainty, that his hands had touched the radios those soldiers carried. Their calculations, their nights of solitary labor, their unauthorized technical decisions had traveled thousands of miles and become a silent part of the survival of men whose names he would never know. In January 1945, the Signal Corps published a formal technical bulletin about the modification. It didn't mention Hartley by name. It described the adaptation as a collaborative development of Signal Corps field technicians and engineers. Technically true, but it obscured the individual's origins. Hartley didn't care. He never sought public recognition. His satisfaction lay in the silent operation of the equipment, not in names engraved on merit plaques. Industrial production continued until April 1945. Approximately 4,700 modified radios were produced and distributed. When the war in Europe ended in May, many of these devices were still in operation. Some were recovered and sent back to the United States. Others were transferred to the Pacific, where they continued to operate during the final months of the conflict against Japan. Modification became so common that many new operators were unaware they were using technically non-standard equipment. They thought it was simply how the 1938 SCR radios worked. After the armistice, Hartley remained in service for another 8 months. He worked on demobilizing equipment, cataloging ordnance, and training civilian technicians for post-war communications maintenance. It was tedious work, devoid of the urgency that had driven his previous years. In January 1946, he received an honorable discharge with the rank of sergeant, a final promotion that arrived unceremoniously, merely as administrative recognition of his length of service and technical contribution. He returned to Detroit. The city had changed. Factories that had produced tanks and planes were now making automobiles again. Men who had left as soldiers returned as veterans, looking for jobs, rebuilding civilian lives. Hartley reopened his small radio shop. He repaired household appliances, installed antennas, and patiently explained to elderly customers how to tune news stations. The work was simple, almost monotonous compared to the war years, but it had its own dignity. Each repaired radio worked better the moment it left his hands. It was a modest but real satisfaction. He never spoke publicly about modifying military radios. When local veterans gathered in bars to share war stories, Hartley drank silently, listened politely, and rarely contributed. If asked directly about his service, he would say only that he had worked in communications on bases in the United States. Nothing more. The full truth seemed inadequate for casual conversation. How could one explain that technical decisions made alone in an empty warehouse at 2 a.m. had rippled across thousands of miles and thousands of soldiers? How could one describe the quiet responsibility of knowing that men lived or died, in part because an oscillator circuit was stabilized, because a filter was added, because an antenna was reconfigured? In 1952, the Signal Corps published an updated technical manual for field radios. The standard design of the new SCR 508 incorporated several of the modifications Hartley had introduced 8 years earlier: thermal oscillator stabilization, improved audio filtering, optimized antenna efficiency. There was no mention of the origin of these improvements. They had simply become part of institutional technical knowledge, absorbed and refined until no one could remember how or when they had arisen. Hartley received a copy of the manual in the mail from a former Signal Corps colleague. He read it through in one night, technical notes in the margins, recognizing principles he had discovered empirically, now formalized in academic engineering language. There was a strange satisfaction in it. His improvised work had become established science. The private soldier's madcap modification had become official doctrine. He put the manual on a shelf among electronic component catalogs and commercial circuit diagrams, where it remained for the rest of his life. Thomas Eugene Hartley died in 1983 at the age of 65 at his home in Detroit. The obituary in the local newspaper mentioned his military service briefly. A veteran of World War II, he served in the Signal Corps. 16 words to summarize years that had changed how thousands of men communicated in combat. There was no military ceremony, no posthumous medals, just a simple funeral, attended by family and friends who knew him as a competent technician, a quiet man, someone who repaired radios with quiet skill. But in military archives, in operational reports archived in Department of Defense warehouses, in technical manuals still consulted by historians of military technology, the modification persists, not as a grandiose story of individual heroism, but as a silent example of how real wars are won. Not just through brilliant strategies or extraordinary courage, but through thousands of small technical improvements, implemented by people who see problems and decide to solve them, even when they lack formal authorization to try. War isn't just combat. It's logistics, communication, maintenance, and adaptation. It's soldiers modifying equipment in empty warehouses because they know it can work better. It's officers risking their careers to authorize unregulated improvements because men are dying for lack of them. It's the sum of countless individual decisions, both technical and human, that transform machines into tools of survival. Hartley's modification didn't change the outcome of the war. It didn't guarantee victory in any decisive battle, but it allowed thousands of voices to cross impossible distances, reach ears that needed to hear them, and coordinate movements that saved lives. And in the end, perhaps that's what matters. Not the glory, not the recognition, Just the silent knowledge that when it mattered, someone saw the problem and solved it. With technical precision, with moral responsibility, with hands stained with solder, and the calm certainty that they had done what needed to be done. If you've made it this far, I hope this story has shown how quiet innovations can change destinies in times of war. If you enjoyed this content, please like it, share it with those who also enjoy military history, and subscribe to the channel for more forgotten stories from World War II. See you in the next episode.